Good morning. Okay, so this is going to be a today. Nah, so I was thinking about modeling stuff, like using actual, equations and stuff, because not just a shape in my head, just to get a little more rigorous, or at least plain, nice and geometric imagery. So I was thinking about it, and in my model, basically, there's inflows and outflows. Electrons are inflows, divergence. Positrons are outflows, convergences. And then mass particles are photons trapped over their own mass, which sort of sit in that inflow or outflow, because other side is reverse time, etc. You can watch some of my other videos. But basically, so let's just say that there's three axes. There's the electric charge, there's the movement of an electric charge, and then there's the rotation of an electric charge in an orbit. Those are the three sort of EM fields. That's why there's three axes, that's why there's three quarks, that's why there's three kinds of neutrino, because it's like a wobbling thing. I think it's addressed in my thing. Anyways, so in modeling, let's just here we go to sphere. Okay, and what's cool about you just plug in a sphere, and I know this is wonk, but and now I'm going to go like this, and it's like, okay, so now we have like sphere, right? So what's that called is de Sitter space. Oof. Kind of anti-de Sitter space along that one axis. Closed. Oh, closed, open, closed, open, closed, open, right? Very simple. And I'm like, okay, well, so we should have three of those, right? I mean, there's three axes, so let's make three of them. There we go. Okay, and there we go. Let's go open. So in my model, this would be a proton, okay, or this is the charge, maybe a positron, but actually, as we look at the charge component, okay, this is an active thing though, right? It's expanding out, it's affecting space forever around it. But we're going to bring it in. And now, poof, it's contained, right? But it's still bulging outwards, like this would be at a process of poof. Okay, notice at this point though, like right now, there are very clear axes. 1, 2, 3 axes, right? And then as I bring it in, oops, there we go. As we contain it, there's this weird phase change, and I know it's like a artifact of the computation or whatever, but I just find it very interesting what's about to happen. So we go from a cubic form, so to speak, in this three distinct axes, and then there's a phase transition where suddenly we have a dodecahedral thing. 4, 8, 12. Okay, and if you notice, let's imagine that those, those cones, those outpourings were charge outputs, inflows or outflows, basically like a membrane of flow. Okay, and those were very distinct. There's three distinct axes, but notice all of a sudden on this form, which essentially contains the same equation, I didn't modify the equation at all, is way more distributed, so that like an outflow here could sort of like balances with its opposite right away. It's almost like the same way that a toroid coil contains the magnetic field within its core. The charge flows out, flows in, flows out, flows in. Everything's little loops that arc across, like on the surface of a sun when you have like one of those, you know, where it reconnects immediately. Whereas when you have it in its open phase, its charge effect phase, so to speak, its outward phase, its gregarious mode, it stretches across eternity before coming back to the other side. You know, that's why I say it's like electron field or something like this more, whereas, or proton, only because, poof, when it pulls in, you know, this would be the model, it is, but then it's a neutron because it's like super compacted onto itself. And yet at the same time, there's a neutron perturbation that makes them decay, which must be something about like a interaction of photons with each other or something like that. So they cause wobble, right? Anyway, just some thoughts on this. This is just like x squared plus z squared equals thingy, x squared plus y squared equals z squared, and then you just throw one of them as the negative to change the axis of expansion on it. I could talk more about that. Super simple, but I just thought that this especially was fascinating.